Hey guys, this is Ulrich from Nostalgic Mathematics. Today we will try to solve a problem from the Austrian Federal Competition 2021. We are given positive real numbers a, b, c such that a plus b plus c equals 1. And we'd like to find the maximum of a over 2a plus 1 plus b over 3b plus 1 plus c over 6c plus 1. In this video, I'm going to show you two ways of solving this problem, and then I'll let you choose the one you prefer. If you're new here, do not forget to subscribe. Let's call as ABC the quantity we want to maximize. We will write as this using multiplicative factors in order to have the same number in bold both in the numerator and in the denominator as here and here and here. What is interesting is that we see a function appearing. Actually, it is a function fx equals x over x plus 1. So SABC is a combination of the images of 2a, 3b, and 6c. We also notice that these coefficients sum each other to 1. So we may want to apply Jensen inequality. But before applying Jensen inequality, we should know about the convexity of the function f. That's what we do computing the first derivative of the function, which is 1 over x plus 1 squared. And therefore, we compute again the second derivative, which is negative 2 over x plus 1 cubed, which is negative. So f is a concave function. So therefore, we can apply Jensen inequality. That is, because f is concave, the convex combination of the images is less or equal to the image of the convex combination, as here. So using that, the number multiplied by its inverse is 1. We have as ABC is less or equal to f of a plus b plus c. We recall that a plus b plus c equals 1. So therefore, S of A, B, C is less or equal to F1. But here, F1 gives 1/2. So as ABC is less or equal to 1/2. Actually, we have an upper bound, which is 1/2. So we'll try to see if this upper bound can be reached. So what about the equality case? Of course, we have equality in the Jensen inequality when all the points we are computing the function for are equal. That is here 2a, 3b, or 6c. So equality holds when these points 2a, 3b, and 6c are equal. So we'll write everything in terms of a. We have b equals 2a over 3, and then c equals a over 3. We replace here, so we have 1 equals a plus 2a over 3 plus a over 3, and the whole gives 2a. So 2a equals 1. So we deduce that a is 1/2. And we replace a here, we have b is 1/3. And replacing a here, we have c is 1/6. That is s 1/2, 1/3, 1/6 equals the half. That is, the upper bound is reached, so we know the maximum is 1/2, and the problem is solved. We use the same setup as in the first solution. We write in as this. We see that the terms in bold have the form x over x plus 1. So we may focus on x over x plus 1. We will rewrite x over x plus 1 as an harmonic mean up to a factor. That's why I personally think that this solution is maybe for those who are more used to inequalities. So x over x plus 1 equals this when we divide both numerator and denominator by x. And we know that 1 is 1 over 1. Now we apply the AMHM inequality. That is, the harmonic mean is less or equal to the arithmetic mean. With z equal x and t equals 1, we have this. And divided by 2, we have x over x plus 1 is less or equal to x plus 1 over 4. Now we apply this result with x equals 2a, and x equals 3b, and x equals 6c. Next, we switch the denominator to have this, and again, we rearrange the terms. In bold, we have a here and 1/2. In green, we have b here and 1/3. In red, we have c here and 1/6. We recall that a plus b plus c equals 1. So this inequality becomes this, because a plus b plus c is 1, and these fractions sum up to 1. And therefore, SABC is less or equal to 1/2. Now we're gonna look at the equality case. The equality holds if you have equality in the AM-HM inequality. But in the AM-HM inequality, equality holds if the two numbers are equal. That is, if 2A equals 1, 3B equals 1, and 6C equals 1. That's what we wrote here. Fortunately, this yields A equals 1/2, B 1/3, and C 1/6. And the sum of these numbers is 1. So all the constraints are satisfied, and we have the equality when A equals 1/2, B 1/3, and C 1/6. So this upper bound 1/2 is reached. So the maximum we were looking for is 1/2. Thank you for your attention. Again, do not forget to subscribe, like, and post your comments. Bye.